So, okay, I think we can start. So, welcome to Percona Live. So, today we are going to present MongoDB security feature. So, I hope you enjoyed. So, let's go. Hello, my name is Jean da Silva. I'm a support engineer at Percona from São Paulo, Brazil. Speaking a little about me, I'm a student of database engineer and big data here in Brazil as well. So in my free time, I like to watch Formula One and spend that time with my family. So if you have any question or would like to talk a little bit more after the meeting, feel free to reach me over the LinkedIn. I will be there. Or also you can use the Q&A tab over the chat, and I'll try to answer a question at the end of the meeting. Okay? So this is the agenda for today. The topics we are going to discuss are authorization and authentication, external authentication, external authorization, network encryption, auditing, log reduction, at rest, and client field encryption. Okay. The objective for this meeting is to revisit security features that are implemented in Mongo and provide can use to help your company, your project, when asked what Mongo can do in terms of security. Okay. The motivation starts from the current scenario that we live nowadays in terms of how and if we should protect information. News about leakage, it's common and increasing day by day. In this chart, in this visualization, we have only the top 5 data breaches per year. So we can see the number are quite high, and in 2020 it's a little bit more than the others. And for 2021, the study shows that it's even worse than 2020. So with that in mind, if you look at the Mongo configuration after a clean install, I think it's a good idea to look at the security because it's pretty simple. Start with only the to the basics of the operation. So yeah. Why not use the security features from Mongo after a clean start? Yeah, it's important to mention that it's not applying all the features is not a guarantee that your database is safe for hackers or attacks. It's a mutual effort, so we cannot rely only on the database guy to do the security role on the database and then let the surrounding unprotected. So this is the idea, and let's move on. The first topic will be authorization and authentication. So some definitions it's needed to be given. So authorization and authentication, they are different features but work together. We cannot enable authorization without enabling authentication. So once we enable authorization, it enforces authorization as well. So what is authorization and what is authentication? Authorization is about what the users can do in the database. It's the role, the permissions, what the limitations the user has over the database. The authentication is the method, is to verify if the users can proceed to use the database. So who is interested in the default configuration? I think it's no one's interested on that, but if you have a guy on your company which can easily go and walk through the database and search and do everything he needs, so this guy will be interested. So of course, in security perspective, it's not the ideal scenario. So by default, the authentication and authorization are not enabled. So with the basics, as I showed in the beginning, anyone can just connect to the database and do whatever they want. So to enable, it's pretty simple. First, we need to create the user, which will be responsible to administrate the other user and give the right roles. Yeah. Once we have this user, we can then restart the instance with the authorization configuration. So it's pretty simple. For command line, you can use --auth, or for configuration file, you can use authorization enabled. After configuring the user, enable it, you have a more stricter and controlled environment. In this scenario, that guy that just were able to connect to the database and do whatever it needs. So at this moment, that problem was mitigated, because right now you have users with the correct roles, you have the authentications enabled, so the user needs to pass the authentication method before joining to the database. So then we increasing more the security. The default authentication for client and Mongo is Scruncha, which is basically user, password, and database, which is authenticating. But we have more authenticating methods as we see in this presentation. So you might be thinking, how does it work for a replica set or a sharded cluster? So when we enforce access control for on the node, if you are using replica set or sharded cluster, we are also enforcing internal authentication for the users. The internal authentication is the method that MongoDB connects to the other to talk and perform administrative tasks. If you enforce access control, you need to configure the internal authentication. The internal authentication can be done by using key file, which uses Scram, that's the user, password, and database, or X509 that requires network encryption. Minimum to your configuration, but you can use X509 with TLS to increase even more your security. Then when we have the authentication enabled and going to the log, we can see the internal authentication from the nodes happening. In this log, for example, we have the mechanism that is using Scram. So I can say you that's using key file as authentication method. It's using the __ system as role, which is in the database the most powerful role that you can grant to a user. So bear in mind that this role is just only for administrative tasks and only for internal users. If you are going to use it, so pay attention to not giving more permission than the user needs. And then this internal authentication uses the local database to authenticate. Okay. As mentioned, we also have external authentication. So far, so good. We have normal client authentication, which is the connection between the client and the database. We have the internal authentication, which is the enforcing method that the MongoDB connect to the other MongoDBs to perform administrative tasks. And now you also have the external authentications, which we can use LDAP, Active Directory, or Kerberos to perform it. Okay, you might be thinking, why I would need to use external authentication? That's because Mongo, unfortunately, does not support items like password length, password complexity, user lockout, expiration. These kind of guidelines are not on Mongo. So for some security policy, it can be required. So the external authentication comes to the game to help in this area. With the external authentication, you can also set complexity, expiration, lookout, and all the things that the user does not provide at the moment, and probably your security is requiring this configuration. So external authentication is an extensive topic, which I would like to recommend you for further understanding and further review of that, to check Sandra. She's our key engineer. She provided a very awesome presentation last year explaining about this integration with Mongo and external authentication. Over there, she deploys the environment, she shows how it works, the modules for external authentication, all the things that needs. Okay. So another question, is the external authentication an enterprise feature? It depends. If you are using the Mongo binary, you need to have the enterprise feature, the enterprise binary. However, if you are using Percona Server for Mongo, you can use it. You can use it for free. So Percona Server for Mongo has this integration with external authentication as well. Okay. Moving on. Another feature from Mongo, transport encryption. Why? Because transport traffic is not encrypted by default in Mongo. Transport traffic is the connection between the client and the MongoD and the MongoD to the other Mongo. So this is not encrypted, and for security guidelines, it's also required to be configured. If we look at the network transport without encryption enabled, we can easily check what's going on over the wire. In the example, and you are using the default configuration, which was disabled. We inserted just one document into the collection, and use the TCP dump. We can easily capture. We were able to capture the data being transferred. The point here is one small part of your information cannot be a big issue, but think that you are using a backup like a MongoDump, which is the most common, and the guy starting to watch your network from the start at the end of the MongoDump. The MongoDump is a logical backup, so it's just checking the data over the MongoD and copying to the MongoDump file. So over the entire operation, the guy who is sniffing your network will be able to see your entire database you are dumping. So in this moment, it can be a big problem instead of just a small part of our database, as in this example. So to configure the TLS, we need to choose the certificates and key. When you have the certificates and key, you need to deploy over all your MongoD and MongoOS configuration. The certificates can be created by you, by your OS administrator, but of course, for production environment and for security guidelines, it's highly recommended to use certificate authority to generate those files in order to avoid any issues related to security breach. Okay. So during the configuration of the network of the traffic transmission encryption, we have to pay attention on the SSL mode. That's because you are setting how flexible is your connection, allowing encrypted or non-encrypted connection. For example, for production, it is recommended to use the required TLS as mode. That's because this mode accepts only encrypted connection from the client to the MongoD and encrypted connection between the MongoDs as well. However, you can also flex it a bit using preferred TLS or also using allow TLS. Allow TLS, it's used when you are deploying the encrypted method in an existing cluster that you need to perform some steps before encrypted as well. So allowing TLS in this example, the client and the node can or cannot use an encrypted connection, and the MongoD between MongoD can use an encrypted connection. So it's more flexible than the others. Okay. Another feature that I think it's important to have on your Mongo environment, it's using auditing. Auditing, it's not help to mitigate security threat, but helps you to investigate and track what's happening on your database, on what's happening on modifications. When we audit the database, each operation can be monitored and tracked to the log. So the log can be the console, direct to the console, syslog, JSON log file, or BSON file. The audit feature is available only for enterprise feature in MongoDB, or you can also use it for free in Percona Server for MongoDB as well. When we enable audit, we are tracking events. So events like schema change, authentication, and authorization. However, different from the authorization, authentication, and then also network encryption, enabling auditing can heavily impact the performance on your environment depending on the configuration you are going to use. That's because you are starting to write more data into the log file. So this data, depending on the configuration, can increase the I/O throughput on the disk. So you can the audit events logs. You can audit everything on your database for some security requirement, but that's not recommended because just to avoid this kind of issue on your deployment. To configure, it's quite simple again. You can use it over the configuration file, passing the configuration. It's using first you choose your format, the file, and then the path. You can also use it over the command line in the MongoDB initialization. In this example, when we enable audit, it audit all the possible operations that we can use. If you are not interested to check everything that's happening on your database, you can narrow down this filter. You can narrow down this auditing is used using filter. The filter helps you to just check what you need, so what your security guideline needs for auditing. In this example, we filtered only for find, insert, delete, and update and modify events. And then when you go to the audit log, we can see the operation on the audit trail as well. Another feature which I believe is interesting and most required on security to comply with security is log reduction. The log reduction in Mongo works a little bit different. That's because depending, it prevents you to write sensitive data in the log. This kind of this log turns the analysis on troubleshoot a little bit more difficult because the data now is covered, but also it's possible, but still able to help us in the troubleshoot for any issue on the database. The log reduction helps because Mongo transfer the data over the log unencrypted. So if you are using one operation in your database, that's in this operation using some SSN number or something like it's exposed, it will be logged on the log on the normal MongoDB log. So this feature is available on enterprise feature and Percona Server Mongo as well. Then to enable, different from the others, we can do it at the runtime with admin command or set it over the configuration file. In this example, we can see how the Mongo redact the log. It uses the hashtag symbol over the information. That's because, as I said, if you are inserting or moving personal information, unfortunately, Mongo will log it over its log. Okay. And then last, and then not the least, but it's about encryption, data at rest and client field encryption. Data at rest, it's available only for White Tiger storage engine only. When we enable it, we enable for all the database, it's included even the admin database. It's important to have in mind that the encryption is not the part of replication. That means if you encrypt your primary, you need to go to the secondary and encrypt it as well. So the data on primary is encrypted on the disk, not on the memory, and then go to the secondary. So it needs to be encrypted node per node. So data encryption on disk and then data encryption over the transfer over the wire with TLS, it's a good security policy to apply on your environment. That's because you are talking it in this presentation. So to configure data at rest, you can use local key file. However, local key file is not recommended on productive environment. That's because you are storing the key file, which is the key to encrypt and unencrypt the data on the same side of the data on the disk. So if someone steals that key, your data will not be able to be unencrypted anymore. So you can use it for test purpose only, but for production, you strongly recommended to use key management services. For example, Percona has integration with HashiCorp Key Vault, so you can store your key vault in the server outside the node which is encrypted, and then do the communication to perform the encryption and encryption when required. And Mongo Enterprise also has this key management with the other tools as well, outside the Mongo as you're talking. So, do I need a separate master key for each member in the replica set or sharded cluster? It's not mandatory. You can use the same key for the nodes, but in a security perspective, it's better to have a different key, because if you lose one key from one node, you lose you will lose only that key. The other node you'll be safe because the key is still stored correctly. If you lose one key that is using for all the nodes, if you lose that key, all nodes are in problem. How I would recover the database if I lose the master key? As I said, if you lose the master key and you don't have any backup of this master key, your data is lost. However, you can also use logical backups. That's because the encryption is on the disk only. So when you do the backup is not encrypted. So you can have an encrypted backup, and then if you lose the master key, you can restore that encrypted data to the node again. Okay. And the new feature that was implemented in Mongo 4.2 is the client field encryption. Different from the disk, the data at rest encryption, the client field encryption is done by the driver. So you need to check if your driver supports this method. Once it's supported, you can do it manually or automatically, depending on which binary or which configuration are you using. You will see it more in the next slides. So it basically encrypt the data different from the data at rest. It's encrypted data on the disk, and this information is encrypted over all the nodes. So this is the positive point using client field encryption. Sorry. As I said, it will depend on which method, on which binary are you using. If you are using Percona Server or the community server, you need to encrypt it manually. That's because the automatic encryption it's available only on Enterpriser or Atlas for Mongo. So the manual mode needs to be done over the application for each field on the document. So does Percona Server for MongoDB support client-side encryption? Yes, that's because it's not a database responsibility, but a driver responsibility. If you configure your driver to set up this encryption, you will be able to use it. For that, we have an example of how to manually encrypt the field. That's because you are using the Percona binary to the presentation. So first, to manually encrypt, you need to create a encryption key. In this example, we are using the key file. So as I said before, local key file is not recommended because if you lost this file, your data will be encrypted forever. So Only for testing purposes, you can use an encryption key, but if you are going to production, you can use management services to store your key. For Mongo support, Amazon, Azure, Google, and local key is one of the services as well. But for production, it's highly recommended to use a third product services. Okay. Once you have this encryption key created, local key created, we can connect to Mongo. We can connect to Mongo, and as you see in the first snippet, in number 2, our local key file was loaded into an object, into the database, and then we created the encryption configuration. That's needed because you cannot connect to the database and then load the encryption configuration from the database. You need to load it first to be able to use it later. Okay. So in this example, in number 3, in the number 3, we create the encryption configuration using the local key file as a reference to our key. Once we have the object, the encryption configuration object, we can now connect to the database, authenticating, because just let me go back a little. Here we use it -- no DB, so we are not authenticating to any DB. We connect it only to configure, to enable the encryption configuration. But then once you have it finished, you can pass it over your connection. Once you have it over your connection, on the number 5, we can create the vault object to store the key the key file, which will encrypt your fields on the document. So once you have created, so in the number 6, we create the key, passing the configuration we authenticated, and then on number 7, we used this UID key generated on number 6 to encrypt the field. So in this example, we are encrypting the SSN field using the UID generated before. So then, at this point, if you connect with a normal user and try to find an information, a collection find a document over that collection, the SSN field will be encrypted. That's because we encrypted it before over our Mongo shell, but you can do it, of course, over your driver. It's important to mention that, unfortunately, if you like to encrypt every single field in your document, you need to do manually for each field. We cannot encrypt the document at once. So this is the requirement using client-side field encryption at this moment on version 4.4. Let's see in the future, maybe they make it easier to use. So after enabling, you may have some questions. Can a root user be able to read the fields? No. That's because what dictates if the users will be able to read the fields is the key. So that's because that's important to store the key correctly. Without the key, the user won't be able to read it. So even the user has the root privilege on the database, and the information is stored, encrypted, and safe. How does it work in a replica set or shared cluster? In the data at rest, it's encrypted only the data on disk. But on the client encryption, the data is transferred to the secondary or to the client encrypted. So you are safe in this scenario. So once you have it, all your information is encrypted from start to the end. And the summary of this presentation, apart from the data at rest encryption and the client encryption, all the features we talked today here are present on our Percona server for Mongo, or also in enterprise feature. So that's a good point, because I mean, you can help your company with security guidelines, and you don't have to spend much more money on to use an enterprise an advanced binary. Okay, and then checking what the security vulnerabilities against the security features. We have this chart which clarifies to us if you are which clarifies to us mm, which clarifies to us what the features can do to mitigate the vulnerability. For example, if you would like to mitigate database privilege abuse, you can use authentication and authorization. Avoid network sniffing, you can use TLS and network encryption. If you'd like to prevent the data being leaked unencrypted for everyone, you can encrypt the data on disk with data at rest, or you can also use the client-side field level encryption to encrypt the data from start to the end. So if this information is leaked or if this information is being sniffed over the wire, it's encrypted, so it's safe to use as well. So that's it. I hope you like it. Thanks for joining this meeting. If you have any questions, so feel free to ask me. I will try to answer most of you. Okay? Thank you. Bye bye.